Okay, thank you for the introduction, Mr. Chairman. And what I want to do is to give a broad overview of what we have in the Netherlands in terms of subsidence and the impacts of that due to deep sources of compaction, the deep sources of subsidence. So you see the beautiful picture out of space. So what you see here is the Netherlands from the northwest. And I think, does this work? We are about here, I think. So now somewhere here. Yeah. Is that right? No? Here. Here. Oh, I was pointing to Utrecht. No, of course, we are now in Delft. Yes, of all places. And Delft is somewhere here, I guess. Yeah. Oh, this is Zealand, yeah. So I'll continue. So what you here see is Netherlands also from space, and this is from the European Space Agency, the European Ground Motion Service. And already from this picture, you see two things in the Netherlands. So what you have here is the Groningen gas field. So if I put a red dot on it, it's really red. What you also see here is more red, but that's Germany. And that's because of coal mining. And here you see blue. This is all coal mining, but that's coal mining that has stopped. And now it's coming up again. And I'll tell you a little about that later. So what is the problem? First question. How does this problem come into being? What do we know? What do we not know? What do we have in terms of measurements? How to improve what we know? Where to focus research? And of course, the question in the end, does it help? This is a kind of an outline of what I'm going to cover today. So what is the problem of surface movement? Well, I think we are almost at the end of the conference, so you now all know it is vulnerability to flooding, it is saltwater intrusion, it is damage if you have differential subsidence. It's the increased cost of water pumping, which is important when you have large areas that are reduced in level. And often you can also have competing interests, like houses with different kinds of foundations, which we will see tomorrow in Gouda, which we have also here in Delft. Different interests of agriculture and sustainable landscape. So those are different interests and give different demands. And rural versus urban. Boeren en burgers. So I think you are all acquainted with this now as well, but I will just give a little feeling of what I'm going to talk about. We have seen a lot of work on soft soils, and I will not cover that in this presentation. It is important, but I'll now focus on deep causes. I'll start with the Limburg mine area, and I have not seen all the presentations, but I haven't heard about it yet. These mines were excavated during the second half, or the third quarter of the last century, 1940, 1970. Groundwater levels were decreased a lot, hundreds of meters, and now they are increasing again, and it gives sinkholes and uplift and differential movements. A second that I want to cover is salt solution mining, which you also do in the Netherlands. When you do solution mining, you make big caverns, and they may creep and give changes in the or give movements, and also result in subsidence. And as a result, you can have problems, especially when you are going to abandon them because you don't know what will happen after that. And maybe you want to use these for storage as well. So there you want also to know what will happen. I will talk briefly about gas production, and I will touch upon geothermal operations if I have time. But I think you have seen this picture. So in the Netherlands, we are having a heavily used subsurface with many activities in the subsurface, shallow and deep, and I will just go on now. So I mentioned these four topics. So Limburg, the coal mines, the former coal mines, the salt caverns, salt mining, gas, and the geothermal. I will start with Limburg. In Limburg, there were former coal mines, and what is important to model that is to know that it is carboniferous, that it has been mined, and that is at different depths. So here you see a cross-section between east and west. So the further you come to the west, the deeper it gets. So the geological setting and the history of this is quite important to be able to model it. When the mines were closed, the groundwater levels were allowed to come up again. And that is what you see here. So they started somewhere hundreds of meters below the surface, and then we are now somewhere here, and it's still increasing. So we want to know what is happening. This gives surface movement at the moment, still going on. And what I do here is I have different concessions. So in these different concessions are connected to the different lines, the different regimes of groundwater increase. So that may give differential movements on the edges. So when I look, for instance, at this little line, which is between two different sections, you will see an effect. Zoom in, and this is what you see when you look at the INSAR. Now, it may not be that clear, but you see here really different colors at this side of the line and at this side of the line. So this side of the line corresponds to this side here, and the other side is more to the northeast, and you see more uplift to the northeast. So that can give differential movements at the boundary where there is a fault which makes the distinction between the two regimes. So there's a response of both the carboniferous and the overburden, and there's an interaction with shallow processes, which really requires an integrated approach to say something sensible about it. The salt caverns, they're mostly in the northeast of the Netherlands. So what is done is a hole is drilled, water is pumped in, fresh water is pumped in, salt water is pumped out, and a cavern develops. And that can be used for salt mining, but also for storage. This may give instabilities during production, and so you want to cover those. But what you will need to know there is to know the behavior of the salt that reacts around this cavern. And salt, rock salt, behaves very, very differently from sandstone. So there is creep, there is stable creep, there is transient creep, and the constitutive behavior here is really important. Now, what you see here is the effect of the creep rate as a result of the effective stress. And what you see is that there is two regimes. This regime is what you can measure in the lab. And this regime is what you will see in the field. So it is really important to have a feeling of especially this transition from the one regime into the other regime, and that makes it quite complicated. On top of that, there's the matter of geometry. If you are having a salt cavern in a salt dome that behaves very, very differently from a salt cavern in an extended layer. And that is what you see here. You see influence functions, subsidence influence functions as a result of different combinations of geometry and constitutive model. So you really want to know what happens. So also here, on top of that, you may have interference between caverns in a cavern field. And also here, it is really important to have an integrated approach. Gas production. I want to cover briefly two pieces of information here. One is the big, giant Groningen gas field, and some of you may have seen the presentation by Rob van Ijs yesterday, which gives a real good overview. And there's also gas fields in the Waddenzee, which have a different kind of impact and have also to be treated differently. So I want to cover these two briefly. In the Waddenzee, what we have is something like 10 fields there, and they're in a very sensitive nature area. So we want to protect that. What happens in a gas field is that the pressure is reduced. As a result, there will be depleting gas fields and depleting aquifers. The question is how much. As a result of that, there will be compaction both in this gas field and in the aquifer. And this will result in subsidence. Now, in the Waddenzee, what you have there is a very dynamic system, a morphological system where water is going in and out. It's a tidal system, which is dry with low tide, and it's flooded with high tide. And what you see here is the difference in height between 2016 and 1927, so that is about a period of 100 years. So you see how dynamic it is, and that these channels where sand is eroded and deposited is changing all the time. So that makes the impact also different. So the impact here is, I just told you, there's interference with this tidal basin dynamics, and the impact needs also to be governed in a different way, because what is important here is the volume loss in a tidal basin. And I think Hans de Waal has told you also something about it yesterday, if you have been at this presentation. The solution that was found is to look at the effective capacity for subsidence. So you start with a certain net amount of sand that comes into the system out of the North Sea, and that can be used to keep the system in equilibrium. Now, for instance, this will be an average of 6 millimeter per year, and then some of that room will be taken by the sea level rise, which is now around 2 millimeter per year, but will increase in the future. And then you want to see how much you still have left and can be taken by the gas fields that you are producing. And this is the way we currently treat that in the Netherlands. So here you see for one of these systems what the contribution is of the Ameland gas field and of the Nest gas field, and then the requirement is that it is altogether, it is below the effective capacity, so below the average rate of sand that is coming into the system. Very important here, of course, is that you measure and control, that you're sure that this situation does not exceed the limits that you have imposed beforehand. And also here, integration is key. What do you know, what we don't know? Just a couple of things about Groningen. We know fairly well the pressure history of the field. So that is something that is known quite well because we have all these measurements in the wells. As a result of that, we can quite well calculate what the compaction in the field is, and as a result, what is the subsidence resulting from that, and that has been calibrated also to measurements. Here as well, there's interference with salt mines, because in this part of the field in the southeast, there's also salt mines, which give an additional subsidence. And it may cause damage, especially in terms of the groundwater management. And also there may be damage if there's interference with shallow sources of subsidence and with the groundwater level itself. There may be long-term effects, and Rob told us something about it yesterday, because this giant gas field is connected to aquifers at the site, and they may continue to be depleted. And it is very hard to make an estimate for that because it's a slow process in the first place, and in the second place, we do not have many wells there. So here as well, what we did is make an estimate of what we could expect in the next 100 years after closure of the gas field. And what you see here is the base case in 2021 or 2025. No, this is, yeah, this is 2025. Here we have 2081, and here we have 2126. So this is 100 years from now. And what you see here is the difference of the two. And then you see that in the northeast, northwest, and in the southwest, there will be some additional subsidence going on, which continues for the next 100 years. I will go a bit quicker because I see somebody going here. What you will have in geothermal is there's limited effect because usually there's equilibrium between injection and production, but there may be some effect of the cooling. Measurements. We have leveling, PS-INSAR. We want to combine it with subsurface knowledge and data. Here you see that there's many causes of subsidence, and you want to disentangle them because different contributions come from different gas fields or from different sources. Essential is to knowledge of uncertainties and error margins, so we need data assimilation schemes. And measurements. So here you see this nice formula in which you can do a data assimilation. I will not go into much detail on that for this moment. So the question is how to improve. And we think really an integrated approach is necessary. This is the main thing that is necessary. We need to integrate different kinds of knowledge. And an example of that is the loss policy cycle, on which Esther will tell us a bit more. Another example is the subsidence model chain, where we start with the geology and the activities, and then calculate the subsidence, and then make a connection to the damage that is resulting from that, which is also quite an active debate at this moment. And we can do integral data assimilation, which we go through the full loop of prior knowledge, models, forecast, and then put into that observed subsidence and come to better knowledge and a better constrained model. We need the knowledge. We need the in-depth studies that we are seeing here all this conference. We need the couplings. We need monitoring results, data. We need critically uncertainty quantification, because a number without an uncertainty measure is useless. We need the integration of disciplines, of research institutes. We need peer review. We need governance, and we need the public. It is an integrated thing where we need all of this together. My last question was, does it help? And for that, my answer would be, let us make sure that it will help. And let us go to Gouda tomorrow. Thank you.
Thank you very much, Peter. We have time for just one quick question. Anyone?
Yeah, thanks, Peter, for an interesting presentation. A question is, with all those different effects on top of each other and relating that to the measurements, to what extent can you or will you be able to take the different foundation levels of the measurements into account?
Yeah, that's an interesting thought, and it has been tried, and I think Ramon has shown something on the first day, that you can indeed sometimes say something about shallow and deep causes of subsidence by distinguishing between the top of buildings and the streets that give reflections. So the streets then will give information about the total, and the tops will give information about deep causes because they are based on founded objects. So yes, absolutely, that is one of the things that can be included in these kind of analysis.
Well, thank you very much.